Welcome, gentlemen, to volume, mass, and something we call density. Let's first talk about volume. Volume is anything that has mass and takes up space. Well, that's matter too, but it takes up space. Anything that takes up space is volume, and it's generally measured by something's length times its width times its height. If it's cylindrical, or if it's a rectangular, square, something like that. If it's a cylinder, it's pi r squared, which is the radius, times the height of the container. Okay, so that's volume. We're all familiar with volume, as in the example of the Dr. Pepper can here. Oops, sorry lads. Dr. Pepper can here. We are all familiar with volume. Down here we've got 12 ounces is what we're most familiar with, but what we're more concerned about here is the 355 milliliters that is represented by the Dr. Pepper. If you ever look at the can, of course you know that you're familiar with 2-liter bottles, etc., etc. But 355 mLs is a 12-ounce can. That's the last we're going to have on the 12-ounce can for now. So as we said, volume is length times width times height. So for example, let's say we had a rectangle that was 12 centimeters by 15 centimeters by 11 centimeters. So length, width, height. And it really doesn't matter which is which when we do this. It just goes to show us that no matter which way we put the rectangle, something else could be the height, width, length, whichever way we just placed it on the ground. So for what we're doing right now, this is fine. So when we take our length and width and height, one of the things that we multiply those three together and we get 1,980 cubic centimeters. That's the volume of this particular rectangle. And here's a cool thing. 1,980 cubic centimeters is also 1,980 mLs. Isn't that cool? So a milliliter is the same as what we call a centimeter cubed. And long story short, I'll explain it in class later as to how all that works out. But for right now, just believe me when I tell you that 1 centimeter cubed is equal to 1 milliliter. Now, just so you have a reference point on that, if we look at our 1,980 cubic centimeters and we divide that by the volume of one can of soda, it's approximately 5.6 cans of soda is our 1,980 cubic centimeter rectangle. So about a 6-pack of Dr. Pepper is the same as our rectangle here in volume. So that's volume. So, and we have mass as well, which is the variable m, which is something in grams or kilograms or something with grams along the lines. That's something's mass, right? We know it more commonly as weight, but that's wait till physics on that. We're going to call it mass in grams or kilograms, mostly in grams when we're doing calculations on this. Now, the third part of all this that I'd like to speak to you about is density. Density is a measure of, it's a ratio of the mass divided by the volume. So whatever that number is, we'll call it X. It's going to be in grams per ml or grams per cubic centimeter or some other cubic number or some other volume measurement like liters, hectoliters, whatever it is, and something cubed. It could be meters cubed, it could be kiloliter, or it could be kilometers cubed, whatever it is. So it's always some sort of volume, and it's always some sort of mass. And sometimes the mass can be in kilograms as well. Just depends on the type of problem it is that you're going to work on. So density is a ratio of the mass over the volume. Now here's a cool kind of thing. If the density is greater than 1 gram per centimeter, the object, when you put it in water, will sink. If the density is less than 1 gram I hope I'm writing these correctly, less than 1 gram per centimeter cubed, the object will float in water. Because the density, check out how we write this, the density of water at room temperature is 1 gram per centimeter cubed. So what that means is if I had a 355 mLs of water at room temperature, it would have a mass of 355 grams because water is 1 gram per centimeter. Anything that has a density less than 1 gram per cubic centimeter is going to float. Anything with oil is an example of that. And anything with a density greater than 1 cubic centimeter or 1 gram per cubic centimeter is going to sink. An example of that would be a piece of metal, of any metal. Well, maybe not any metal. Anyway, most metals will sink, right? So this is how we go. Read the problem. Okay, so we want to know density. Density of a metal that has a mass of 21.6 grams and a volume of 12.6 cubic centimeters. Well, let me show you a couple things here. First, density, as we know, density is equal to mass over volume. Now, this is pretty cool. Watch what I do. I'm going to make this triangle. I'm going to put the D down here, the M here, and the V here. Now, let me show you how that works. This is actually pretty cool. Density is equal to mass divided by the volume, right? We know that. I already told you that. Density equals mass over volume. Well, let's say I get a problem where I want to know what the volume is. I want to know what this is. Well, the volume is equal to the mass divided by the density. V equals M over D. See how that operates? Cool. Now, let's say I want to know what's the mass. Well, mass is equal to the density times the volume, because they're next to each other. Density times the volume. So density times the volume is mass. Mass divided by volume is density. And volume is mass divided by the density. Is that not cool or what? So you'll always be given the triangle whenever you do any problems. And hopefully you've got this in your notebook and you've already written it down. But all I've done is put this variable here, and this variable here. Isn't that nice? I thought you'd think so.